Hello everyone. Today in this video we'll be discussing the first module of design and analysis of algorithms. In this video we'll be going through 5 topics which has to do a lot with algorithms and design process. Okay, so we'll be going through very in much detail each topic to give you a clear picture of what the topic is and how can we apply that in real life. Okay, and it's very important subject because the projects which we'll be making in the upcoming semesters and the company's interview process and the competitive programming and in it has a lot of wider uses. Okay, it's the most important subject in this semester, so I'll be going through very slowly and in more detail to make things much clearer as much as I can. Okay, so if you like this video, you can hit the like button and don't forget to subscribe to my channel. Okay, so before without wasting any more time, let's begin with the first topic, which is firstly you need to know what is an algorithm. So for any task which we need to do, like adding two numbers, what's the algorithm for adding two numbers? Okay, suppose that these are two numbers 1 and 2. Okay, for adding two numbers, first you have to take the input of first number, then the input of second number, store it in two places, and then you have to add it by using arithmetic logic unit. Then the result will be stored in the third register, which is 2, and that will be displayed. So the algorithm has 4 steps. First is input, then second is calculation, then third one is storing the result, and the fourth one is displaying. Okay, so that is known as algorithm. Now after knowing what is algorithm, you have to know the sequence of steps needed to solve the problems. So firstly, if the suppose that the problem is to swap two numbers, so there are two variables a and b. A has the value 10, B has the value 5. Now our task is to swap these two numbers in the place of each other. Okay, so what can we do? We can take a third variable as C. First we'll store 10 here, then we'll transfer 5 here, then we'll take this 10 and put in the place of B. Okay, so this is the problem. So first, after understanding the problem, that you have to swap two numbers. Okay, after that you have to decide how you will perform the task. Okay, computational means suppose that you can take the same example as two buckets having two different liquids. Okay, and you have to transfer the contents of each exchange the contents of each bucket. Okay, so you have to decide on computational means what are the resources you have to carry out this task. So in this case we can just go with the simple case of taking a third bucket. So that's the resource required. Then exact versus approximate solving, that means suppose that you have to calculate number of people in a particular area. Okay, it's a very large area, like 100 square kilometer. Okay, 100 square kilometer area is there, and you have to calculate how many people are living in that area. So there are many people living in that area and it will be very hard to count each people. So what can we do is we can go for approximate solving. Exact was for the swapping of two numbers because it's a small task, and for greater task you have to go for approximate. Now what can we do here? We can just calculate the people living in 1 kilometer square. Okay, and then multiply it by 100, so we can get an approximate idea of how many people are living in a very shorter time. Okay, so that's known as the choosing whether you are going to solve the problem by using exact or approximate method. Okay, then we are left with algorithm design technique. Okay, consider a large database which has 10,000 words. Okay, and you have to search one word from the given database. Now what can you do? You have two choices. First one is linear search, which means you will search each word one by one and compare with the word given. Okay, if you found, you will return the word, or else you will keep on searching. So it will take a lot amount of time, and it's a waste of space and time also. So the other method is binary search. What does binary search do? First, it will check if the word is lying in the first half or the second half by comparing if the given word is having the first letter lesser than M or greater than M. That means if it's arranged in alphabetical order, you will be knowing if it's lying here or here. Okay, so suppose the word is noon. Okay, Noon. So what can we do? We can search from the mid part if it lies below M or above M. So we'll get to know that the word is after M, so we need not search 5,000 words. 5,000 words search is eliminated. So only we are left with another 5,000 words. Again we will search if it's greater than suppose q, okay, greater than q or lesser than q. So in this case it will be lesser than q, so we are eliminating more 2500 words more, okay. So the number of iterations will be very less here. So that design technique you have to decide on which design technique will be most efficient in which problem, okay. And after the knowing of design of technique, you have to design the algorithm. This is very simple. We will be just writing a rough sketch of what the algorithm does, and after that we are proving the correctness of algorithm. Means whatever the possible inputs can come um, while using this algorithm, those all inputs should be producing a correct output, okay. So that we will be checking and proving its correctness. Then analyze the algorithm for more efficiencies if you can make the code more efficient, and finally code the algorithm in your any language like Python, C++, or Java, okay. That's the last step so that you can use the algorithm in the system, okay. That's it. The next topic is algorithm specification. What do you understand by the term algorithm specification? That means whenever we are going to write an algorithm, we are specifying how we are going to write the algorithm. That means are we using the simple words of English, or we are going to make a flow chart or the diagrams, or we are using a programming language to write the algorithm, or a combination of above methods, okay. So that way we are specifying what the algorithm and how we are writing the algorithm, okay. Let's understand algorithm specification by using a example. In this example, we have been given with an array, and we have to sort this using selection sort. What does selection sort do? In selection sort, we will be traversing through each element till the last element, and in each iteration, we'll be finding out what's the smallest element. In the first iteration, the smallest element is 1. The first element place will be placing 1. Since it's already 1, we'll move on to the second iteration. In second iteration, we'll be finding the smallest element, and we'll get as 2. So what we'll be doing, 2 will be placed in the second position. So the 2 will be here and 7 will be here, okay. So in that way, third element will be placed in the third position, and the fourth element and the fifth element. In this way, we are sorting the elements. This is known as selection sort. Now, the main idea you got to know now how to represent the idea in the form of an algorithm. So in this algorithm, we'll be using simple English and C++. So what's the first step? You have to write the for loop. Since you are iterating the whole array, you are using a for loop which will be running from I is equal to 1 to I is equal to n, okay. And we are examining each a of I and n, means we are comparing each of element, right, if it's smallest or not. So we have to write examine a of I means this value. If it's 1, a of 1 to a of n, till a of 1 to a of n you will compare. In the second iteration you will get the smallest element here, so you'll start comparison from here. The third iteration will start the comparison from here, and so on. Then suppose the smallest element is at a of j, you will find the smallest element and you will interchange a of I and a of j, okay. So in the first place, you will write the smallest element and interchange the position. In the second iteration, you will write the second smallest element and interchange its position with the previous location. In this way, we are representing the algorithm. Now let's see how to represent the same algorithm using only C++. In C++, we'll be using the syntax of the C++ and writing the same algorithm. Okay, so here the syntax is not important since we are representing by using English and C++. Okay, in the same way you can make a flowchart also which can depict the same thing, like how I made an array, right? That's also a valid algorithm. Okay. The third topic is analysis framework. In this topic, we'll be looking if a particular algorithm is good or not. For that, we'll be looking at two things. First one is time efficiency and space efficiency. Space efficiency is not much important because we are getting a large memory in a smaller chip also nowadays. So space efficiency is not much important. So we'll be focusing more on time efficiency. So in time efficiency, the main thing which matters is input size. If the input size is larger, most of the algorithms will run for longer time, okay. So how is the running time actually measured? See, we can't actually measure the running time exactly, so we are going for approximation method. In approximation method, for example, if it's about sorting algorithm, okay. So in sorting algorithm, what happens is we'll traverse the array and we'll compare each element with the previous element if it's smaller or not, okay. So the main thing is comparison. So what we'll do is we'll count how many times the comparison is being called by the program, okay. Means how many comparisons are being made. For example, if the array has 10 elements, if you're doing a linear sorting, at that time what you'll do, you will go to each location and compare with the previous one, okay. So you're doing 10 iterations in one in the first iteration you are going 10 times through the elements. So the number of elements are there into how many iterations you are going. That will give us the total number of comparisons. Okay, so in that way we'll calculate according to different algorithm techniques, which gives us the least number of comparisons. That will be the algorithm which will take the least time. So there are two functions, and f1 and f2. Okay, f1 and f2 both perform same task, and first one is taking 8 iterations and second one is taking suppose 50 iterations. Okay, so in the orders of growth, this is in the powers of 1 and this is in the powers of 2. Okay, that matters. So in for larger programs, if it's taking 9 or 10 and the second one is taking 10 or 12, it doesn't matter. Okay, that's very less difference. So what matters is if it's n square, n cube, n raised to 4, those things matters. Okay, so for understanding that, first we need to know what is worst case, best case, and average case. In worst case, consider an example of linear search. Okay, so we have the elements, and in the first case we have been given to find out if one is present in the array or not. So we'll get it in the first iteration only. So number of iterations here is 1. So that's the best case. In worst case, if we are given to find the if 5 is present or not, what we'll do, we have to perform 5 iterations, right? So it will be more time consuming. So number of iterations is 5, and it's the worst case. In the third one, if you are given the number to find 3, we'll be going through 3 iterations. So that's an average case. Okay, so that's the difference between the three cases. Coming to performance analysis, we have two things. First one is space complexity and second one is time complexity. So in space complexity, it means how much memory is required by our algorithm to complete its execution. Okay, so that's space complexity. For example, see here in the example of this function, what you have, the variables are here, float a, float b, and float c, and the constant part is 4 here. So for 4, the memory is fixed, it's constant, and the how much more memory is required, it depends on the values of a, b, and c. Okay, so in that case we'll be calculating the space complexity of this function. Similarly, we have time complexity, in which we'll determine the number of times a step is executed. Okay, so for example, in float sum, the how many steps are there? First step is this one. Okay, float s, this will be initialized. Then the second is for loop. In for loop, how many times you're running? N times you're running. Okay, so n times you're running means for each running you will have to calculate s plus is equal to a of I. So for each iteration you will be doing one step. So for n iterations you will be doing n steps. So here one step and n steps here, and finally you will be ending the for loop for that one more step here, and the last one which will be returning the statement, which is return s. Okay, so that one more step. So how many steps are executed? N plus 3. Okay, so these are the total number of steps executed. So that gives us the time complexity of the function. Okay, a standard way to determine the growth of an algorithm is known as asymptotic notations. Okay, in this way we'll calculate the worst case and the best case and the average case. Okay, so let's see one by one. First one is big O notation. In this, consider two functions f of n and g of n. Okay, 3n plus 2 and cn. So what we are trying to do is, for what least value of c, f of n will be less than g of n. So what is f of n? 3n plus 2, and cn is this. So you can calculate, you can take any value of c and see for each value of n it should be less than c of n. So if it is if you take c as 4, then it will be 3n plus 2 is less than 4n. Okay, for all the values of n is greater than 2, you can put any value of n and c which is greater than or equal to 2, which will be less than 4n. Okay, see here, if you put 2 here, it will be 8 here, and 4 into 2 is 8. 8 is less than or equal to 8. Then for 3 also it will be 11 is less than or equal to 2. You can prove this as true because 3n plus 2 is less than or equal to 4n. That means 4n can be written as 3n plus n. Okay, 3n and 3n will get cancelled. So 2 is less than or equal to n, or n can be written as greater than or equal to 2. So for all values of n greater than or equal to 2, this will be true. Okay, this statement. So in that way, we can show that in the same in the graph also. These are time versus input graph. Okay, so these are the inputs, increasing inputs here, and this is the time. Okay, so for f of n, this is f of n. Okay, 3n plus 2. After n is greater than 2, okay, after n is greater than 2, at that time cn, which is 4n, will be always taking more time. Okay, since its value is more, which is 4n. Okay, and this is 3n plus 2. So the more higher the graph like this, the more time it takes. Okay, so in this case, the worst case efficiency in this function is 4n, because whatever value of f of n you put in the place of n, it will always take lesser time than g of n. Okay, because for all the values it will be less than g of n. So in this in that way we can calculate the worst case efficiency. That's represented as f of n is equal to O of g of n. What is g of n? That is 4n. Okay. In the same way, we have big omega notation, which means the f of n should be greater than or equal to g of n. In the previous one, f of n was less than, right? So in this case, it will be greater than. So for what value of c, we can have f of n always greater than g of n, which means if you take c as 3, 3n plus 2, it will become 3n plus, it is 3n plus 2 here. If you take as 3 here, it will be 3n. So it's obvious that 3n plus 2 will always be greater than 3n. So that means f of n is 3n plus 2 and g of n is 3n. Okay, so g of n will always take lesser time than f of n for all the values greater than n naught, which is 0. Okay, for all the values of n naught greater than 0, g of n will take lesser time. Okay, so the best case efficiency, which means the best case, the least time which f of n takes will not be more less than g of n. So that gives us the best time efficiency. That is represented as f of n is equal to big omega of g of n. In big theta notation, we are just calculating the average over the best case and the worst case. Okay, so when we calculate the average, we will be writing the f of n between g1 of n and g2 of n. Okay, so for example, if f of n is 3n plus 2, we will be writing the best case here, which is 3n. Then we will be writing the worst case, which is 4n. So we will be writing the average case as the average of best case and worst case. Okay, so f of n is between 3n and 4n. In case we are given two functions and we have to compare and see the which of the growth is more, at that time what we'll do is we'll write two functions here, f of n and g of n. Then we'll be calculating the limit. Okay, we are dividing f of n by g of n, like 3n plus 2 divided by n square. When we calculate its limit, we'll get as 0. Now there are three cases possible. If it's 0, it means that f of n has smaller growth or a smaller order of growth than g of n. If it is c or any constant, that means it has same order of g of n. If it's infinity, that means f of n has larger order than g of n. Okay, so that three cases are possible, which you have to remember while comparing the growth of two functions. In mathematical analysis of non-recursive and recursive algorithms, we'll be seeing how many times a particular statement is being executed. Okay, so what does non-recursive mean? It's iterating, like by using a for loop, and recursive means it's calling itself in the same function. Okay, so first one you will be looking in non-recursive algorithm. So consider this function a, which has a for loop which runs from I to n, and it prints the letter a. So how many times the letter a will be printed? It's obvious that it's running from I to n, so n times it will be printed. So the number of times the function is iterated is O of n. So n times it's iterated, so the order is n. Okay, we'll be writing O of n. In the second example, we are having two for loops. So how many times a will be printed? For each value of n, j will run from I to n. Okay, so for each value of n, n times will be executed. So how many values of I are there? Till n, right? So n square times the function will be executed. Okay, so that's the order of this function. In the third example, I is running from 1 to, and the condition given is I square is less than or equal to n. That can be written as I is less than or equal to root n. So for all the values of I till root n it reaches, that time it will be executed, right? And a will be printed. So the number of times the function is iterated is O of root n. Okay, because it gets iterated root n times. Okay, so that was about non-recursive algorithms. Recursive algorithms, the function is being called by the same function. Okay, see, a of n is defined as this, and inside a of n we are calling a of n minus 1. So suppose that, what's the time taken by this recursive algorithm? How to calculate that? First, the if, see, this is the comparison. If n is greater than 1, suppose that it takes a constant amount of time c. Okay, and then the time taken for the recursive algorithm. Now total time taken will be t of n, which is equal to c, which is for the comparison, plus time taken for n minus 1. Okay, so t of n is the time taken for a of n, and t of n minus 1 is the time taken for a of n minus 1, and c is the constant time for comparison. Okay, so you can write the general equation as t of n is equal to c plus t of n minus 1. Consider, for instance, the constant amount of time is 1 for simplification purpose. Then t of n is equal to 1 plus t of n minus 1. Now, what is t of n minus 1? In the place of n, substitute the n minus 1. So we'll get t of n minus 1 is equal to 1 plus t of n minus 2. Similarly, t of n minus 2 is 1 plus t of n minus 3. Now, substitute the value of 2 in 1. When we do that, we will get t of n is equal to 1 plus t of n minus 1, that value. Okay, that can be written as 2 plus t of n minus 2. Now 2 plus n minus 2, substitute the value of that in 3. Okay, this value should be substituted in 3. Then what we'll get is t of n is equal to 3 plus t of n minus 3. Okay, in the same way we can write as the general equation t of n is equal to k plus t of n minus k. Now after getting the general equation, when does the execution stop? Means recursive call will stop when n is greater than when n is less than 1. At that time this will not be executed, just the comparison will be done. That means it will take c time and then this will not be taking place. Okay, so that time when n is less than 1 means when n is 0, time taken will be 0. Okay, so at that time what we can write is t of n is equal to k plus t of n minus k. When will this be 0? This will be 0 when n is equal to k. Okay, when n is equal to k, at that time it will be 0 and the times executed is k. Okay, so k means k is nothing but n, so the total number of times executed is t of n, which is n. Okay, since this is 0, we'll be writing t of n is n. Okay, so that's the time complexity of recursive algorithm. Another type of recursive algorithm which is of this form, t of n is equal to 2 times t of n by 2 plus c. Okay, so for example, if this is the program here, see, in this program what happens is it takes a constant amount of time c, and then the remaining time will be 2 times the time taken for t of n by 2. Okay, so how it will be? So for the first time it will be the time c for t of n. Okay, it will be c plus t of n by 2. How much time t of n by 2 takes? 2 times. Okay, so t of n by 2. Now again, what is t of n by 2? T of n by 2 is nothing but 2 times t of n by 4 plus c. Okay, so each of this will take this much amount of time. So how can we write that? We can write it as c plus t of n by 4, and here also t of n by 4. Okay, same thing we have to write here also. Like that it goes on till it becomes t of 1. Okay, so that's what I have made here. So total time will be the sum of these many time taken for each iteration. Okay, so when we reach t of 1, the time taken will be c, because if we put the value of 1 here, it will be t of 2 times t of n by 2. Since n is n should be greater than 1, so when n is less than 1, this value will be 0, so total time will be c. So at last level, total time here will be c for t of 1. And as you can observe, in the first level it is 1c, in the second level 2c, third level 4c, means it's increasing in the orders of 2 power n, right? See, what is t of 1? T of 1 can be written as t of n by n. Okay, so if it's written in the form of t of n by n, we can write nc, because see, it's t of n by 8, we wrote 8c, right? We wrote here 8c. So if it is n by n, which is 1, that means we can write nc. Now the total time taken will be the sum of these factors. Okay, so what will be the sum of the total sum? C here, c plus 2c plus 4c till nc. This is nothing but the geometric progression, and when we apply the value of geometric progression, we'll get the value as c into 2n minus 1. Now as I told you, if you have to calculate the order, we'll just look at what's the value of n. Is it n or n square or n cube and so on. Okay, we'll not look at the coefficient and what is getting subtracted. Okay, so the order is n here. Okay, so this is the another type of recursive algorithm which comes under the topic of mathematical analysis. Okay, the third one is Fibonacci series. As you know, Fibonacci series is the sum of the previous two numbers. Okay, and f of 1 is defined as 1, f of 0 is defined as 0. So t of n will be t of n minus 1 plus t of n minus 2 plus a constant amount of time c. So we'll be doing the same thing. First it will take n is equal to n minus 1 plus n minus 2, and n minus 1 is n minus 2 plus n minus 3. Like that we'll go till we reach the end where it is 0 or 1. Okay, In the same way, we'll write the values of constant time here, which is c, 2c till n minus 1c. Why n minus 1? Because at the last level you will have t of n minus 1 and t of n minus 2. So either of one will be 1 or 0. So if you consider this as 0, then this should be 1, right? So it is t of n minus 1. So at that time we'll get the total sum as c plus 2c plus 4c till 2 raised to n minus 1c. Why 2 raised to n minus 1? Because see here, this 2 can be written as 2 power 1. This can be written as 2 power 2. Till how many terms we are going? Till n minus 1, right? So it's 2 power n minus 1 into c. Now taking c common and applying the formula of geometric progression, we'll be getting the final answer as c into 2 power n minus 1. So it's the order of 2 power n. Okay. The next one is Tower of Hanoi. In Tower of Hanoi, what we are doing, we are printing one statement and calling the Tower of Hanoi 2 times. So how will be the recursive algorithm? It will be t of n plus 2 times t of n minus 1 plus any constant number. Here I have taken c. You can take any constant number. So what is t of 1? In t of 1, this will be 0. So t of 1 will be 1. So we'll write the same thing as t of n as this, and instead of n, we'll write here t of n minus 1 and write the next equation, and we'll be substituting the values and we'll be obtaining this final equation here. Okay, after taking the geometric progression formula, we can write the total time taken as 2 power n minus 1. So the order is 2 power n. Okay, under the topic of important problem types, we will be discussing the problems of sorting, searching, string processing, graph problems, and combinatorial problems. Okay, with one example. So for sorting, what is mainly sorting? We are rearranging the elements in increasing or decreasing order. So to choose the algorithm which works for the best, it depends on the database. If it's a smaller database, some algorithms work better, and some algorithms work better for larger data case. And two things which you need to note down is what is table algorithm. If consider this array here, if it has two elements same here like 8 and 8, after sorting also the first 8 is before the second 8, see here, then this is known as stable algorithm. And the second one is in place algorithm. In place algorithm means it does not require extra memory while sorting the elements. Okay, so that's known as in place algorithm. And the next one is searching. Searching means we have to find a given value from a set of elements. Okay, so there are many algorithms for that. It depends on the database which is larger or shorter. Okay, like binary search or linear search. Third one is string processing. String processing means see, Google database has a lot of information in that, and when we are searching a particular query, we are getting the results within a few milliseconds. So how is that possible? It's because of the algorithms used by the Google, which comes under string processing. Okay, graph problems, it's mainly used in the social media apps like Instagram and LinkedIn. Okay, and also in Google Maps. Now what's a graph? Basically it means a group of nodes which are interconnected. So how can it be used in social media? See, in social media apps there are many users, right? So how those users are connected with each other, and due to that the sharing of data can be possible between each of these. Okay, tutorial problems, we are finding out the best combination among a group of elements. Okay, so for example, these are the food items and these are the scores and the price. Okay, so the satisfaction level is counted and keeping the score as minimum as possible. So in that way we are choosing two or three foods and calculating the score. The score should be the maximum and the price should be less than 300. Okay, so in that way we are calculating the best combination of the foods. So in that way the optimal solution is found, and that type of problems comes under combinatorial problems. Okay, this is also a major field of study in computing. Okay, this is the last topic, and in this topic the previous data structures which we studied, those data structures are being discussed. So let's quickly revise each of these. So first one is linear data structure. It means the arrays and the linked list. Okay, so there are two major applications. First one is stack and another one is queue. And linked list is also having many types like singly linked list, doubly, and circular linked list. Okay, so that's all about linear data structure. Second one is graphs. Graphs means nodes are connected with each other. These are known as vertices, and the connections are known as edges. Okay, and graph can be represented as two types. First one is matrix, and second one is linked list. Okay, then coming to weighted graphs. Weighted graphs means if there is a number associated with each edge, that's known as the weight of the graph. Okay, coming to trees. Trees is same as a graph, but it has no multiple edges or cycles. Okay, it moves on in the downward direction. We have few types. First one is rooted tree. Rooted tree means each of the node can be acting as a root for the another subtrees. Okay. And ordered trees means the adding of the nodes of the elements will be happening from left to right. Okay, first this will be added, then this, and in this order it will be keep on adding. Okay. And binary tree means it has at most two children or two nodes at each position. Okay, at most two means it can have one, 0, 1 or 2. Okay, it can't exceed 2. Binary search tree means in the left subtree all the elements are less than the root, and right subtree all the elements are greater than the root. Okay. In this diagram I have made a bit wrong, but you got the point, right? So that's the binary search tree. Coming to sets and dictionaries, sets is defined as the set of unordered collection of elements. Okay, so this is known as a set, and it can perform the following operations, which is finding union and intersection. And set can be represented by using an array, and these elements will be inserted sequentially in an array. Now what's a dictionary? A dictionary is a type of data structure which can be implemented using arrays, hashing, and balanced search trees. Okay, and it can perform the following operations: searching, inserting, and deleting.